Hello, this presentation is on GraphQL in Sling, around the GraphQL core that I've been writing together with Radu Cotescu in the last few weeks or month even maybe. So we're going to start with a presentation of what GraphQL is, a short introduction in case you're not familiar with it. Then I'll show a demo of a prototype that is based on this Sling GraphQL core and demonstrates some of its important concepts. We'll discuss rendering. We'll see that we can do rendering both server-side and client-side, and I'll show some parts of the implementation, how it works, and what you need to know to work with it. So let's start with a short GraphQL intro. You can find more info in many places. Obviously, it's just so to make sure we're on the same page about it. Here's a typical GraphQL client. This is GraphQL, which is very often used as an interactive client to do queries. So GraphQL is a query language. On the left side here, you see a GraphQL query. And the nice thing is that the shape of the query and of the results, that you see the results on the right side, the shape is similar. It allows you to define pretty precisely the shape of the JSON that you want to get as your results, and also select exactly what fields you want to get or not. We'll see a bit more about that in the demo. So this is the basics of GraphQL as a query language. And GraphQL is driven by a schema which defines the data models that you can query, their data types and everything. And the interesting thing in the Sling GraphQL core is that the schema is generated by an internal Sling request with a .gql schema extension, which means you can use all the flexibility of Sling to generate these schemas, make them specific to resource types, and we'll see that in the demo. I think that's a very interesting aspect of this module. And the schema can be introspected. The clients like GraphQL allow you to look into the schema, find out what about the available types and available queries that you can make. So this is very useful, as a discovery mechanism to discover your data. We're going to see now how it works more concretely. So this is a demo. It's a demo website that I created in the Sling samples module using the Sling GraphQL core. So let me start by showing you the website. So the demo website, it's a very simple website. It shows articles about various topics, categories, news, culture, and so on. The articles, the text is generated by a simple algorithm, so text is a bit funky. And there's many links. It's very rich navigation. You can navigate to next article. The articles have see also. If I click the first one, we see this article about Solon Davis. You can also search articles which have a given set of tags. You can see the URL here. It's the tag separated by plus signs. So it's very rich navigation. It's very fast because it is server-side rendered, as we'll see. And a nice thing about it is that it's driven by. You have a nice JSON rendering as well. You get that for free with this mechanism that we're using. So here, for example, I'm showing the JSON of an article. First, you have a navigation section, which has points to the root of the articles tree, the previous next article, and so on. The search page, the various sections. So all this is nicely rendered in this navigation element of the JSON, and then you have the JSON of the article itself with the title, tags. See also elements that we saw before, and the text of the article itself. So a nicely shaped JSON, which is driven by a GraphQL query, as we'll see. So as I said, all these the basic article pages are server-side rendered, and there's one page that is client-side rendered. It's the search page. this one. So when I do a search, it does an actual request. It shows me 2 articles only with this query. And then I can refine the query by activating or deactivating. Here I'm activating, deactivating the business section. And this filtering happens client-side. If we look at the source code of this search page, so you see here the GraphQL query is executed client-side by making a request to the Sling GraphQL servlet. And then you have the rendering, which uses handlebars templates client-side in this case. So in our demo website, it's only the search page which is client-side rendered because it's more dynamic than the others. And then I can also show you the GraphQL tool. So it's a client-side tool to do queries, which we have here. So on the left, I have a query similar to the one we saw before. It's the same query, search text little, which gives me only 2 articles. So you see the 2 articles on the right. And here in the query, I can define, okay, if I say I don't want the tags field anymore, I can remove it from the query, run the query again, and now I have only the path of the articles. And it's here that I can introspect the schema with this docs button here on the right of GraphQL, which allows me to see the schema. Oh, I see that there's an article object in the schema, path, title, and so on. So this is the schema of the article itself. I see that it has a path, a title, tags, and so on. So then I can use the fields. I can say, okay, I want to see the section, for example. Also, so it's all very convenient to have this schema introspection for to be able to discover the schema. So this is a kind of an overview of this sample. You have here on the slide the various things that I just mentioned. So all the pages on the left are server-side rendered with GraphQL and handlebars running server-side. The search page is rendered client-side, as we mentioned, using the same tools, GraphQL queries, handlebars templates, and you can also run client-side queries directly with a suitable GraphQL client like GraphQL that we use here. So it's very flexible, and this is all driven by the Sling GraphQL Core with little, you just need to write your GraphQL schemas and the data fetchers that we'll see. So there's not a lot of code to write to create a sample like this. Let's discuss rendering a bit more. So this is how the client-side query and rendering works. Nothing very special, So the client does a post request, an HTTP post with the GraphQL query that we saw in GraphQL. It goes to the Sling GraphQL servlet on the right here, which queries the Sling content repository or whatever you want to query. It's completely pluggable, programmable. And then you get the JSON results. And in this case, they're formatted running handlebars templates on the client. So this is kind of the usual way of using GraphQL with the benefit that you can define the queries on the client, and it's very flexible from the client's point of view, and it's only using front-end programming technology, so quite simple to set up. And now this is the server-side query and rendering that my sample is, most of my samples pages are using. And this works using Sling internal requests. So, the Sling scripts resolver is called as usual. It resolves to a .hbs script, which calls my handlebars script engine. And this makes an internal request to the same path, to the same resource with a .json extension. So handlebars uses the JSON rendering provided by Sling of the current resource and applies templates to it to generate the HTML or whatever you want to generate. And then there's another internal request done by the GraphQL script engine to generate the schema. So to render this page server-side, there's actually 3 Sling requests. The main one for the HTML page, then the JSON request that gets the JSON using whatever you have configured. And if you have configured a GQL, a GraphQL server-side script for that, then it calls the GraphQL script engine, which in turn makes another internal Sling request for the schema. So it's a bit inception, three requests going on at the same time, but it gives lots of flexibility to do this server-side rendering. I'm using handlebars here so that I could use the same one on the client and server side. Of course, you could use any suitable template engine. For the prototype, this was a very simple thing to set up, so I found that useful. A few words about the GraphQL Core internals, how it works. So currently the release is 0.04, so it's still early days for this module, but it's still working pretty well. It provides, as mentioned, a script engine. You see here on the top right, the GraphQL script engine, which works for scripts with the GQL extension. So these scripts define the queries that you want to run server-side. There's a GraphQL servlet, which is the access point, the entry point that the GraphQL client or server-side search page was using. You could configure multiple instances of this servlet if you want, with different schemas, with different access control if you want. So it's pretty flexible. And then the API, the core of the API, I think the most important class or interface that you'll use from the API is the Sling data fetcher, which is the object that does the actual query. So the GraphQL core parses the queries, and then it delegates to these data fetchers to get the actual data. We'll see an example in one of the next slides. The schema provider, as mentioned, so the schema provider is an OSGI service, so you could plug your own if you want, but the default one does, as mentioned, an internal request to Sling. So it makes a request to the current resource with a GQL schema extension. So once again, you benefit from the full flexibility of Sling, to generate these schemas using any technology that works for you. So this is all very flexible. Here's the data fetcher that we mentioned. So the interface, basically it has just one method, which is this get method that we see here, which can return either a POJO, a plain a Java object, or a map or key values map, which is what we see here in this example. So you have to implement this. The schema will point to a data fetcher using a schema directive, and then you have to implement these data fetchers to provide the actual data. So there's a few default ones, but in general you will have to define your own, and this is where you have to be careful about performance and all this. We'll talk a bit more about this. The Sling GraphQL Core also supports server-side scripts for these data fetchers, so you could script them in any suitable language that's supported by Sling. Here we have a simple example in JavaScript, in server-side JavaScript once again. So these data fetchers in the end, they are just OSGI services, so you can implement them however you want. About performance. So this is one topic that often comes up when we speak about GraphQL. All these very open queries, what's going to happen? Are the clients going to do crazy things to my data and, create a full table, the equivalent of full table scans or something? So this is what happens when you run a GraphQL query, for example, from GraphQL as we saw. So the data path is that GraphQL will call the Sling GraphQL servlet, which is part of the GraphQL core. This in turn calls the schema generation, the orange part that we see here. So as mentioned, this is a Sling internal request. So here, in general, you're just generating text, so it should be efficient, but you still have to be careful already. Then we're using the GraphQL Java library, which takes care of the parsing, validation of the queries, and delegates to the Sling data fetcher services. And as mentioned, the Sling data fetchers is really where the performance happens, because these are going to collect and aggregate and do any processing to the data that you need, and then GraphQL Java just kind of transparently sends the results to the client. So it's really when you create these linked data fetchers and the GraphQL schemas, you're really defining an API, an API to your data. And you have to be careful. You have to think about performance. You have to think about how many of these fetchers you're calling, maybe profile them. So really the performance is up to you, I would say. And as we evolve, we'll probably provide more out-of-the-box data fetchers, which can be optimized. But at the current state, you have to really provide your own data fetchers and be careful. So I would say that the answer to is GraphQL going to cause performance problems, my answer would be it depends on the efficiency and the structure of your data fetcher services. Another aspect related to performance is caching, and I think caching is a problem with GraphQL. It wasn't. I don't think it was part of the initial design of GraphQL, and in our context of websites or large-scale websites, caching is very important, and especially HTTP caching, because we already have caches and CDNs, content distribution networks. We can do that caching, provided that we follow the HTTP style for that. So what we did, and this is similar to what the Apollo library is doing for caching, is the problem is GraphQL queries are post requests. So in principle, those are not cacheable, or most caches are not configured to cache them. So you need to be cacheable at the HTTP level. You need to do a GET. And this is what we've implemented now in the GraphQL core. To do a cache-friendly request, you first need to post the query text to a special path, which is will persist the request and return a 201 HTTP status, saying, okay, we have created a persisted request, and you can now use it. And to use it, you do a get to the path that was provided, and this actually runs the GraphQL query, returns the results with HTTP headers, cache control headers, which make it cacheable. So you have to kind of prepare your queries in advance. Then you can run them with GET requests, and then you get the query results, and these will be cached in your usual, I would say, HTTP cache or CDN in the front end. This is still evolving. We're still working on this. It will probably be refined, but I think that's a good mechanism to enable large-scale HTTP-driven caching on these queries. We're almost at the end, but this was part of the title, and I think it's an important topic. How about GraphQL and REST? We often hear that people tend to say, "Oh, GraphQL is the opposite of REST." I don't think this makes sense. And Phil Sturgeon, quoted here, agrees. He says the biggest oddity I noticed with the GraphQL with REST conversation is a falsehood that you must pick one. You don't have to pick one. GraphQL is a query language. REST is an architectural style. And I think we can find interesting ways of marrying them. And hopefully my sample demonstrates some of this by running GraphQL queries on the server side. It's a very nice way to aggregate content and prepare nice JSON that you can consume in your templates. And then, hide them between a normal HTTP resource-driven API. So I think that's one way that I find interesting of marrying them. We also saw in the caching section that it's good to think about both HTTP and GraphQL concerns. So I would say, it's I don't think it's one or the other. I think we can definitely find interesting ways of marrying them. And one thing is that GraphQL is certainly better than a badly designed so-called REST API. We see many HTTP APIs which claim to be RESTful, maybe because the URL contains /REST or something, and they're not always well designed. So GraphQL can be better than that. But as we said, when you're creating the GraphQL, the Sling data fetchers, you are defining an API to your data. So it's still going to be complicated at some point if your program is complicated. Okay, so I'm at the end of this talk. We'll have some times for questions and answers, hopefully. So in summary, I like GraphQL. I think it's a very nice query language. And I think it can also be useful on the server side. And we're seeing, as we evolve in this path, and we see the caching concerns, for example, I think there's definitely a place for GraphQL on the server side as well as the client side. Both are useful. And as I said, I don't think it's better or worse than REST. They are very different animals, and they can play nicely together. And hopefully my sample demonstrates this. You have links at the bottom of this slide. The slides will be available, so you can really look at the GraphQL core in more detail, play with it, make pull requests if you see things that we can improve, and the sample is linked from the GraphQL core module page. It's in the Sling samples module. And I just have a link here to the fake content generator. I think that's a fun tool if you need to generate text for samples like this one. That's very useful. Thank you for listening, and let's see if we have some questions that I can answer. I would be happy to. Thanks.